Thank you everyone who has participated in my events of yesterday and today, which will make this show a little bit more interesting. So, moving on, my name is Troy Hunt. You can get me on any of the contacts up there. I'm a Microsoft Most Valuable Professional for Developer Security. Find me on Twitter at Troy Hunt. The other thing I'm going to do, I've queued up a bunch of tweets that should go out at the right times here, which will have links and references and things like that. So if you want to get more info on the things I'm talking about, they should hopefully be on the Twitters in the next 50 minutes throughout the presentation. I'm also a Pluralsight author, so there's a couple of courses I've written, and some of the things I'm going to talk about today are from my course, Hack Yourself First, and I've also got a bunch of free passes if anyone doesn't have a Pluralsight course. Come and grab some of those later on. Okay, so let me jump into it. Now, the idea about the talk today is what I call Hack Yourself First. And the idea here is to try and help you learn how to break your own applications before somebody else does. Let's just repeat that. Break your own applications before somebody else does. We are going to look at things which may be used to break applications that are not your own, so obviously exercise a little bit of discretion there. Now, we're going to cover a bunch of things, so very, very quickly. How to get a credit card whenever you need one. This is very, very useful, and you won't believe how easy this is. We're going to look at how you might theoretically break into Mercedes-Benz, among others. Anyone got kids? This is a good one? Got kids? Yep. Love this, family game. Free access to airport lounge Wi-Fi, that one's extremely useful. Usernames and passwords, I believe. Usernames and passwords sent over SSL, and we're going to talk a little bit about insufficient use of SSL. Hijacking insecure mobile device requests from around you. I think some of you may have seen this, but we'll see a first-hand demo. Also cracking passwords. So we're going to do a little bit of password cracking against cryptographically stored passwords that you probably think are secure, but you're not going to think so much after that. And we're going to finish by painting a toilet just to keep it interesting. Now, if it all goes well, you're going to leave petrified and have a really terrible week next week fixing all the holes in any websites you look after. And maybe finding holes in other people's websites. But anyway, let's move on past that. All right, so here's where I want to start. So I thought what we might begin by looking at is just the ease with which many applications are compromised. And it's interesting because at the moment everyone's talking about the NSA is hacking everybody and the NSA is influencing cryptographic standards and random number generators and very, very high-tech stuff. But what's amazing is just the simplicity with which we are dealing with a lot of attacks on the web. So I thought we would start here, and we would start with the bit about the credit card. So obviously credit cards are one of the things we put a lot of effort into protecting on the web. So we've got standards like PCI DSS and all sorts of expectations from payment card providers about how we're meant to handle their details. Now, I went and grabbed a bunch of credit cards before this session because I thought this would give a bit of context. These are all real credit cards, they're all valid, they're all recent. Anyone want to take a guess at where I got these? Oh man, you guys have seen this already. Okay, I got these off Twitter because, this is the social world, right? So people get a new credit card and they go, how awesome is this? They take a photo. They put it on Twitter. There's a Twitter account called Need a Debit Card. So you can all go and have a look at that. It should be tweeted out from my account. So you go on and need a debit card and all these people are going, oh, I got this awesome credit card. I like this one. I'm so happy. So that is a very, very low bar, and we probably wouldn't really consider it hacking, but I just thought it was interesting when we're talking about sort of serious risks and things like that, just how easy it sometimes is to get this data that we put so much effort into protecting. So credit cards is one example. Now I thought we'd move on, and we'll make it a little bit harder, but still very, very easy. We might talk a little bit about Google. So I think everyone's familiar with the concept of a Google Doc, right? So particular searches you can do that find things on the web that you're probably not meant to find, or that aren't meant to be there anyway. So let's start with an example. And I'm going to jump over to a little search here. I'm going to grab this text. Well, actually, let's take a look at this text first. So what are we going to do here? We're going to look at where the URL contains FTP. So you might not know this, but Google indexes FTP as well. It's not just HTTP resources, it will index FTP. We're going to look for web.config, which in ASP.NET has all your configuration settings, including things like connection strings through to databases. And we're going to make sure the file type is a config. So it should actually get web.configs over exposed FTP. So let's see what we can get. Okay. Oh, wow, look at that. That's a lot of results. So 5,500 results, including Mercedes-Benz. Now I'm showing Mercedes, well, I'm showing it, I mean it's a bloody Google result, you know, we're not exactly hacking here. Apparently they have been notified as well, but they just weren't that interested in it, which is kind of odd. So here's the interesting thing. So we've got 5,500 results there of configuration files that have everything from sort of how to connect to your database to how to connect to APIs. Once I how to connect, API keys, usernames, passwords, all sorts of stuff. Now the other interesting thing is that that is just the web.config file, and it's found it because there's anonymous access enabled via FTP. You take out that web.config, I'm told, and you will find directory listings. And what do you get in directory listings? You get things like database backups, because some people think it's a good idea to back up the database and put it on a public bloody website. Database backups then have everything from, you know, passwords to credit cards to whatever else it may be. So extremely low-hanging fruit there. When you do start to filter this down a little bit as well, so you can sort of start to look at, okay, well, what about passwords? So, you know, how many passwords might we have floating around in here? And all of these we're seeing here are connection strings. Actually, I like this one. So this one here. And it's really good because it's actually a really good password. This guy's gone, how good am I? I'm going to make this awesome password. I'm going to put it on bloody public FTP. So these are the things that happens, and you can sort of filter these queries down. You filter them down and look at things like connection strings that are using, say, the SA account, so the server administrator account, the God rights account. And of course, the reality of it is then you've got access into the database, and the database has got however many other databases on it, and everything sort of starts to unravel from there. So Google is extremely easy for finding these sort of risks. All right, so those we probably couldn't really call hacking. It's like, yeah, I can look at a Twitter account and I know how to do a Google search. And obviously we didn't click through things there. Mind you, it would be web directions IP address that was doing it, wouldn't it? But anyway, we won't do that. So moving on, let's start looking at some real attacks. And I thought what we might start to look at here is SQL injection. And just out of interest, anyone got a handle on SQL injection? Who understands, has a good idea? So maybe half the room, okay. Well, let's do a quick little recap, and then I'll show you a really, really easy way to do SQL injection. So, the recap is this. When you have a URL like this, you really have two parts. So you have a resource, which is going to be the protocol, it's going to be the host, it's going to be the path, it's going to be the name of a query string, and then you have a query string value. Okay, so pretty obvious stuff. Now, commonly that translates down into a SQL statement. And this would be a fairly typical sort of SQL statement. And in that SQL statement, we have the query and we have the parameter. And obviously what's happening here is that the query string is being passed into the parameter. Now, there's two parts to all of this. And one part is that everything on the left-hand side of the screen is trusted. And it's trusted insofar as we built it, we know what it is, we control it, we have confidence in the integrity. Assuming the server hasn't been owned, and that's a whole other story altogether. Now, on the right-hand side, we have the untrusted data. And by untrusted, what we're saying here is that this data could be manipulated by someone. And you can go and manipulate the query string, and let's say change 3 to a 4. Okay, it's not hacking, you're going to get product 4 instead of product 3. The point is that it's changed, and it actually changes the execution of the stored procedure or the SQL statement that sits underneath it. So what you can do then is the sort of stuff that's on my t-shirt, and you can start manipulating that query string parameter. So what if, for example, after that 3, we put a semicolon, which would close off the statement, and then we wrote something like drop table product, and then we put a dash dash, which would comment out anything after that. Now, if we passed that in the query string and it persisted down into the SQL statement, that would be a case of SQL injection. And if the account that the web application is using to connect to the database has the rights to drop tables, then your table is nuked. Does that make sense? Okay. All right, but it's a little bit hard. So I'll show you who's really good at doing this, okay? So this guy here, this is my 3-year-old, okay? Now, as you can see, he's a lit hacksaw. And I'm going to show you how I did this. I actually did a video with him where I taught him how to do this. So the link has been tweeted. It should be there. So let's do this. Now, what we're going to do is I'm going to jump over to this website. Now, this website is part of that course I mentioned earlier on, and this website, anyone can go to, it's public, you can go and hack the hell out of it if you like, hackyourselffirst.troyhunt.com. It's got around 50, 60 fairly serious vulnerabilities, including SQL injection, and this is what I use to try and demonstrate the risk. Now, the theory is that you go through and you rate various cars, and you sort of figure out which one you like the best, and what you can do then is go and look at, say, let's go and look at all the Nissans, okay, and it will load a page, and this page has a query string, okay? So this is effectively what we just looked at, where this is the untrusted data. That's a very, very standard pattern for building web applications. Nothing wrong with that in and of itself. Let us now copy that. I'm going to go down, open a tool called Havage. It's the little carrot down here. My son loved it because it was a carrot. All right, so what we're going to do with Havage. Now, Havage, in theory, and you've got to look at this, it's penetration testing tool. Penetration testing. It is a free tool. You can go and grab it off the web from itsecteam.com. There's also a paid version that does more advanced versions of SQL injection. We're going to look at a very simple SQL injection attack, and it's going to be an error-based SQL injection attack. So I won't go into the details of what's happening underneath, but basically with an error-based SQL injection attack, what's happening is we're making requests to a web application in order to cause it to generate an error. Now, if that error discloses the internal implementation of the database, then we can use that to start figuring out what's inside it. So, for example, that one before where I said, okay, well, what if we did sort of drop product? If the database doesn't have a table called products, and it raises an exception which says there is no table called product, and the web application exposes that into the interface, then it's sort of disclosing what's happening internally. Anyway, let's move on. So we're going to paste that URL into the target, and we're going to hit the Analyze button. Now again, you can go and do this right now. You can go and grab Havage. My website is designed to do this so that everyone can go and do that without getting into any trouble. Now what it's doing is it's making HTTP requests. So what you've got to remember is all of this is happening over HTTP. It's not like it's sitting down inside ADO.net or making direct database connections or anything like that. It's actually going through and just making requests out over the web. And hopefully it will actually finish doing that and work. Now what it's trying to do is it's trying to make requests in such a way that the web application starts to disclose what's happening underneath. So it wants to find out, okay, what's the name of the tables, for example? What's the name of the database? And it's sitting there and it's not going anywhere. So if that doesn't work in about 2 seconds, oops, I'm going to go to my backup one, which is running locally, which would fix things right up. So let's go to the local one. Looking. So what I find really interesting about this, just while things are trying to actually work, is often we see hackers in the news, okay? So we see 16, 17-year-old kids. And you sort of look at it and go, you know, these guys are just kids. How are they doing this? Well, a lot of the time, it's just these sort of free automated tools, which makes life extremely easy for them. So we're going to roll over to backup, the one running locally. Oh, there you go. The real one's actually worked. I think we just got a really slow internet connection. This will be interesting. So right down the bottom here, here's what it's found. DB name, hackyourselffirst_DB. That is the name of the database in my Azure instance, my Windows Azure Cloud Service instance of this application. So that is an internal name. It's gotten that internal name. Now that it has that, we can go up and say we would like to get the tables in that database. So let's say get tables. And what's going to happen now is Havage is going out and making requests in order to try and disclose the internal table structure of that database. And again, all it's doing is it's just issuing individual HTTP requests. It's going extremely slowly, but what we'll see here is we've got one table called webpages_membership, and it's just going to go through and continue to discover what those tables are. Now, since it's going so slowly, I'll explain how it does it. So what it will do is it'll do things like try and reconstruct a SQL statement which selects from, say, the sys.tables table. So within most databases, there are system tables that contain the names of all the tables and the names of all the columns and things like that. Now, by querying those, it's actually finding out the names of everything else that's in the database. And once it finds out that, then we can go through and start doing things like looking at what is in the individual tables. So normally you'll have, I mean, this is obviously a very, very small database, but we might have something like user profile. And let's say we want to see what is inside user profile. Hopefully that is the last of the tables. Just about there. Okay, good. All right, that's found all those. Now let's go and get the columns out of user profiles. Now normally this goes really, really quick and everyone just goes, oh wow, how easy was that? That was really, really fast. It's not going quite so quick today. But this is going to be the same sort of thing. So it's now going through and saying, okay, list all the columns that are going to be in that database. And I'm actually going to just short circuit this and I'm going to take that URL because that is just going way too slow. Let's go to my local one and it should fly. Stop previous job. Okay. Exit, do it again. All right, that's better. Okay, tables. Get all the tables. Okay, I want to get all the user profile columns. And okay, here are all the columns in our database. I want the email, the first name, the last name, and the password. Thank you very much. Get the data, and there's all your data. Wow, wow. Isn't it magic? I told you a 3-year-old can do it. If you can copy and paste, you can mount a SQL injection attack. So again, what I find so sort of interesting about this is, first of all, the level of automation of attacks. So this is just extremely simple. And secondly, it puts a little bit of context to these attackers that we see on the news, you know, the anonymous, you know, you see the photos, the kids are turning up at court, their mum's always there, the mum's always really pissed because the kid's going to go to jail for using these tools. But that is how easy it is to mount some of these attacks. So give Havage a go, it's kind of interesting. But you know, again, put this back in the context of hacking yourself first. So it's a good way of actually looking at your own applications and seeing if you have vulnerabilities. You can do this against your own live running applications just by putting the URL in, seeing what comes back. Now, it's not exhaustive. This is only doing an error-based SQL injection attack. It won't do more advanced injection attacks, like say a Boolean-based attack or a blind-based attack. You've got to spend money on tools. But it's a starting point, and there are lots of sites that are vulnerable to it. Okay. So I thought we might have a bit of a look at mobile as well, because obviously everything is now extremely mobile. Everyone is sitting there with mobile things. And one of the things that I'm finding is that security in mobile devices is just absolutely shocking. And specifically what I mean by that is the security of how the devices talk to web services. So I'm a very web-centric guy, and I'm interested in what's happening over HTTP. So I thought what I'd do is I'll give you a few examples of some of the things I'm seeing, and then I'll show you how I'm finding these and how you can find them in your own apps. So let me start with an example here. So I was working with someone recently, and they had an app that was, well, what's the right way to say this? Maybe a little bit promiscuous. But what it would do, and it was very, very easy to find this, and I'll show you how I found it. But basically what it was doing is it was hitting a web service over HTTP, part of the legitimate use of the app, and it was very easy from this web service to find the WSDL, the Web Service Definition Language, and to then go through and find other services that were also exposed in that WSDL. Now, one of those services allowed you to retrieve every single user in the system, including their username, including their password, which is stunning. And it takes about 2 minutes to find it. And the way I did it is I used Fiddler, and I'm going to show you Fiddler in a moment. And after I found this, I said to the guys, you know, this is really bad. All I did is I loaded Fiddler and I found this. And he said, yeah, but our users don't use Fiddler. Right. They fixed that. All right, so here's another example. Now, this one is around SSL, and we're going to look a bit at SSL today too. But one of the interesting things about SSL is that you've got to make sure it's actually working. And what I mean by that is SSL is a certificate-based mechanism whereby you will get a certificate from the server. There is a process by which the certificate is validated. If it is valid, then you know the traffic is sound and it hasn't been manipulated or anything like that. Now, a particular bank here in Australia, who I won't name, decided to turn off the validation. And the only reason I found this is because I was doing another talk recently and I wanted to use this bank as an example of how to do it right, because they were doing it right and it was perfect. And at some point in time, what they've done is they've said, okay, well, we're actually going to turn off certificate validation. Now, often this happens because it makes it easy. Developers can create self-signed certificates, put it on their web service, and then they don't get the phone sort of throwing its arms up and going nuts. So just turn off the validation. They didn't even realise. This is a big four bank in Australia, and effectively their mobile app was rendered completely insecure. at least in terms of the traffic. So pretty serious stuff, and it's a bank. If a bank can't get it right, come on. And if I have to find it, they didn't find it, and that's what's sort of a little bit stunning. All right, one more before we go into a demo. So shopping centre. There's a shopping centre I looked at a little while back, a couple of years ago, and they had an app for consumers, and consumers could use this app to perform various tasks within the shopping centre. I won't say which one it is, but you'll probably find it if you look at my blog. And one of the things that happened here is that there was a service that was actually on an IP address, which seems kind of odd to stand up an app with a dependency on an IP. But anyway, it was an IP address, and it was hitting a web service path. Now, once you took that path out and you just went back to the root of the IP address, there's all the shopping centre control systems. No authentication, no access controls, no nothing. Which was kind of amazing, and I spoke to the guy who was doing it, and I said, okay, why'd you do it? He said, well, it made it really, really easy to manage the shopping centre because we could just use this one set of services for everything. And there's a bit of a theme here. We did it because it made it easy. And it's not like it's that hard to go, okay, well, why don't you take those bits and put them there in your own sort of internal network? But this is what tends to happen. Okay, so here's the demo I want to give. And this will show you how I'm finding these things. So this is obviously my iPhone. And what I've done here on my iPhone is I've set the HTTP proxy. Now, the HTTP proxy here is going to be the bits down the middle, down the bottom. So you can see the server has got an IP address. And that IP address is the IP address of my PC. I've then got a port which is 8888. Now, let me show you what is running on my PC. If we get rid of Havage, because we don't have that anymore, and we jump over to Fiddler. Now, who's used Fiddler out of interest? Wow, there's a lot of, maybe a third. And has anyone tried proxying mobile traffic through Fiddler? All right, so I've got a very small number, so hopefully this will be new to a lot of people. Now, it's very, very easy. All you do is you open up Fiddler, you go into Tools, Fiddler Options, Connections, and you make sure that it allows remote computers to connect. Now, once you do this, every request, HTTP request that I make from here is going to go through Fiddler. Now, we're going to check it's working, and with the internet the way it is, it may work very, very slowly, but as long as we can see connections, that'll be good. Okay, so I've just loaded my website on my mobile device, and you can see there that we're starting to get requests. So effectively, these are all the requests that are loading off troyhunt.com. So what that means is that I know my phone is proxying data through there. So I'm going to close that app. I'm going to delete all the traffic. Now, what I'm going to do next is I'm going to open this app. So this is British Airways. This is their app. Now, their app has a facility where if you are an executive club member, which is effectively their loyalty program, and you have access to lounges, you can sign in with your credentials. And when you sign in with your credentials, and it authorises you, and it knows who you are, it will give you the passwords to the lounge Wi-Fi. Let's open the app and see what's happening. I'll delete that traffic, and then I'll go through and I'll find British Airways, and we'll open the app, and we'll see what happens. So we can see requests, HTTP requests going through. And what we're going to do is we're going to click on the second request here. You can just see lounge there in the URL. It's returned a gzip HTTP compressed response, so we'll uncompress that. We'll look at the raw response, and guess what? Here are all their lounge passwords for Wi-Fi. Hey, look at that. How handy is that? So here's the lesson. Every HTTP request that your app makes on your device, even if it's over SSL, if you own the device and you can control it, you can see the traffic. So basically what's happening here is it's a lack of access controls. So there is no access control that makes sure that you're actually an executive club member before it loads up all the data. Now this is really important, and this is the way I find so many of these vulnerabilities, because it's almost, you know, when you're in a web browser and you've got a URL and you're on your PC or your Mac and you can manipulate the URL, you can view the source code, everything is very much in your face. It's very much in front of you. When it's an API or a service behind a mobile client, it's much, much harder to see that HTTP stack. I mean, it's not really hard. I just showed you how easy it is. But it's much harder when you're sitting there testing, building it, developing it, to see what's behind that stack. It means that a lot of stuff gets through that I just don't see get through in web applications. So the real lesson there is make sure that you do go through and look at the requests that your devices are making if you're building APIs. Go through and then try and manipulate those requests. Tools like Fiddler, and this is a big part of my course as well, are very, very easy to go in and just reconstruct the request, change a few parameters and see what happens. What if I try to request a resource with a different ID to the one that was actually loaded? Does it load anyway because there's no access control? Perfect example. Okay. So that one was very, very easy. All right, so let's start to get towards talking about SSL and Wi-Fi's and things like that, and then it will get really interesting. We're going to start by talking about what a man-in-the-middle attack is, because when we talk about SSL and HTTPS, what we're worried about is an MITM, or man-in-the-middle attack. And I want to try and give you an example of what a man-in-the-middle attack is. Okay, now... I actually made this slide last month and it felt really, really relevant, but how old does this feel already? Thank God it's over. Oh. All right, so think back to middle of the year and we had Jules and Kev, and if everyone remembers, there was a bit of a brouhaha, and effectively, Jules was saying, Kev, do I have your support? You know, because I think you want to knife me. And Kev goes, no, I want your job. Now, we know that this is what Kev was saying, but everyone saw Jules stand up and said, no, I got the support of everybody loves me, everything's fine. So, what happened? There must have been a man in the middle, okay? Now, the way a man in the middle attack works is the man in the middle gets the message, same message, legitimate message, and they manipulate it, you see? So this is obviously why Jules thought she had support. The message has been manipulated. So in the context of a communication layer, what we're really saying is that a man-in-the-middle attack happens when someone is able to get in there, in the middle of the communication between two parties, and either manipulate it, like we just saw here, or observe it. Okay, so this is why we always have SSL, because we're worried about the fact that people might actually get in the middle and observe or change our traffic. So I want to give you a couple of examples of how we're getting SSL wrong. And the way I want to do this first is just show you all the points where we might have a man-in-the-middle attack. And one of the things that I find happens very frequently is people say, oh, it's very hypothetical, it's very academic, it doesn't really happen. And this is why many of you have been participants in my experiment yesterday and today, because it does happen and it's very, very easy to happen. Now, the risk is that there's a lot of things that happen in the life cycle of an HTTP request. So this is probably the wrong conference to put a Surface up, but let's imagine it's an iPad. And your iPad, or wireless device or whatever, makes a request to a wireless access point. Now, it doesn't have to be wireless, but wireless is the greatest risk because we just have so many devices and they're also trusting, as we'll see in a moment. Now, that goes through to your wireless access point. Your wireless access point then goes out over the wires, over public connections, over Telstra's cables, goes to an ISP somewhere, goes all around the world, and finally ends up at the NSA, or or hopefully a legitimate server somewhere. Okay, so that's the first half. Now what happens then is we have a response. Now a response, it's just the same thing, right? It's just in reverse. All the way back through the public phone lines, into the access point, into the device. Now the point in terms of transport layer protection is every single one of those points is a risk. Okay, so every single one of those points, if someone is able to get in the middle of the traffic and do the Tony Abbott thing from before, they are able to either observe or manipulate unprotected traffic. Now, had to have one. Let me give you an example of how this happens, and we'll make this a little bit interactive. So I'm going to go back to this website we were just talking about. And what I'm going to do is I'm going to go to the login page. Okay, now logging in with credentials is the sort of thing that we often talk about in terms of transport layer protection. You know, we need to protect it because it's people's passwords. And if you get someone's password, you can log into this site and you can log into every other bloody site that they've used the same password on because that's what people do. Now, when we look at this page, is this a secure page to enter your login credentials into? No, I'm hearing no. So why are we saying no? Okay, so there is no HTTPS in the address bar. Okay, we don't have a little padlock. Oh, and by the way, padlocks. Don't put padlock gifs on the page. It doesn't make it secure. Honestly, the number of times you see that, no, you don't get it. Okay, now, you're right, the page has been loaded over HTTP. But what if I showed you this, okay? What if we look in the source code and we look for the form, and it's just here, and we can see that it's actually going to post to HTTPS. Okay, so when the credentials get sent, they're going to get sent over a secure connection. Is this secure? No. All right, why not? Oh man, this is an intelligent audience now. This is going to make the demo a bit slow. All right, but let me show you. Actually, I won't repeat what you said because this way it'll be a little bit of a surprise for those who didn't hear it. Okay, so what we're going to do, first of all, we've got Fiddler running over here. I'll delete all the requests that are in there. Let's just log in, okay? Password with a 0, so no one will figure it out. Log in. Okay, cool. We are logged in. We can see it does actually say hello Troy up there now. Very good. All right, now let's look at Fiddler. Now what we see in Fiddler is there is no request here to that path we just saw in the form action. So we're not actually seeing the credentials posted. The credentials were posted over SSL. We couldn't see them. Now this is a very, very common pattern. You see it on many websites today where you will see username, password, text boxes loaded in the clear, but it will post over HTTPS. Now, let me show you what we're going to do here with Fiddler. What I'm going to do is jump into Fiddler's script. And what Fiddler's script does is allows us to control the way the requests are working. Now, actually, let me explain why I'm using Fiddler here. Everything is obviously on my machine. I'm going to load the website on my machine. I've got Fiddler on my machine. But Fiddler, in this capacity, is just working as an HTTP proxy. What we're going to do now, and what Fiddler could do, is it could be at any one of those points along that HTTP request lifecycle. It could be at the wireless access point, could be at the ISP. And I'll give you an example about where it's been done at the ISP before as well. So Fiddler is effectively being our man in the middle. So we're going to jump into Fiddler's on-before response event. Now what this on-before response event lets us do is manipulate the contents of the response after it's been sent from the server, but before it hits the client. And I'm going to uncomment a little bit of code I got here. Now what this code is going to do is it's going to look for HTML pages, and it's actually going to inject a bit of script into the page. It's going to inject this from a page on the internet, and in fact it's going to inject a little JavaScript keylogger. So what I'm going to do is just save that script. I'm going to go back to the website. I'm going to log off. And then I'm going to go to the login page. Now what I'm going to do, because this will make it more interesting, I'll whack that over to the side so we can see Fiddler behind it. Now let's start entering the email address. Keeping in mind as well, this is a live running site. You can go and do this all day long with this site if you want to have a play with it yourself. Now have a look on the left. As I start to type my username, you see all those little requests? So what's happening is that the keylogger is asynchronously making HTTP requests. Okay, because there's a little JavaScript keylogger in there. It looks for the on-key press event. Every time it sees an on-key press event, it gets the key that was just pressed, and it sends it off over the internet to the attacker. Let me just zoom in on that a little bit, and you'll see what's happening. Okay, so it's first of all of this is going off to the attacker domain, and if we have a look down here, it's passed in the query string, so we can just see there's .com, hotmail.com, and my password is PASSW0RD. All right. Now, when I submit that form, the credentials will be encrypted because it is going to be an HTTP request. It's too late. Everything's already been sent off to the attacker. And this is the point of forms that load over HTTP but then post to HTTPS. And it's why people just don't get it when they say, look, my form loads over HTTP, but it posts to HTTPS. And they're always very proud of it. Oh, it posts to HTTPS, it must be okay. The same thing happens a lot when you see login forms loaded over HTTPS but embedded into an iframe. So if you've got an HTTP page and you've got an iframe that's got a source, it doesn't matter what happens after that, it's an HTTP page. The source of the iframe could be manipulated. I've got demos of both those on my blog as well, and I think my live tweets hopefully just sent that out. So if you want to go and see how that's done, there's actually videos of how that happens, effectively what you just saw here. But if you need to show someone to explain why you cannot load forms over HTTP, that's a good one. The other thing that's really important about it is people often say, you know, and again we come back to this point about, oh, it's very academic and everything. If you're using SSL at all, you're acknowledging a man-in-the-middle risk. You're saying, I am going to encrypt my protocol because I'm worried about someone getting in the middle. If you're worried about that, you can't just do it in that bit and miss this big bit over here. But it happens. And it is a paddling. So, let's move on. Alrighty, this little guy. Okay, so, as I was saying before, a lot of people view risks such as man-in-the-middle attacks on HTTP traffic as being very academic. And a really good way to demonstrate that it's not academic is to actually show you how easy it is to capture people's traffic. So I want to talk about this little guy here. The lights are flashing. This is a Wi-Fi pineapple. So yesterday I wandered around, and I was sitting at the back, and I walked around for a little bit as well, and I had the Wi-Fi pineapple running, and a bunch of you got pineappled. You didn't even feel it, but you got pineappled. So let me explain what it means to get pineappled. So, if you Google it, turn Safe Search on. So basically, this is a little wireless access point, all right? And incidentally, it's $100 off the web. You know, this is not sort of super-duper penetration testing equipment that costs thousands of dollars. $100 off the web. It's got a little wireless radio in it. So effectively, it can become a wireless access point. Some of you might have seen free Wi-Fi, and free Wi-Fi is always very attractive. Now, what happens is a lot of people go, oh, free Wi-Fi, great, I'm going to jump on. Now, when they jump on, what can happen is the Ethernet cable that goes into my PC can route their traffic through the PC, and then the PC might do things like just capture it all. In fact, you don't even need to capture it on the PC. It's running a little embedded Linux version. It's got a micro SD card in there with gigabytes worth of space. It could just capture every piece of traffic that goes through there. Now, you might think, okay, well, that's great, but I'm not stupid enough to connect to free Wi-Fi. Incidentally, some of you are, because some of you did. But here's the interesting thing, and this is what many people don't realize about Wi-Fi. So what happens is all of these little devices that we all have, and I've got, I mean, geez, in my bag I've got my iPhone, my iPad, I've got my PC, and I've got my Surface Pro as a backup as well. It's 4 different things, all sending Wi-Fi signals. Now what they do is they send what you call probe requests. And a probe request is basically a request for a known network. So you know how when you get home, you automatically connect to your home network? That's because your device is saying, where's my network, where's my network, where's my network? Yesterday, I picked up 997 probe requests for networks. These are your networks, okay? So your devices were running around saying, give me this one, give me this one, give me this one. I know that's going too fast and it's too much to read, so one of my tweets has got a link to this on Pastebin. You can go and see if your Wi-Fi is on there. Now, there's no risk in that insofar as all it is an SSID name, okay? You can drive past your house and pick up the same thing. But the interesting thing is that what you can see is these are all the different networks that this one device is trying to connect to. Funny, some of them as well. You can figure out where people are going. You'll have, Airpoint Lounge, coffee shop, Madame Lash's parlour. You see some very weird stuff. Okay, so the device can see that. It sees all those probe requests. Now, what it can do then is it can turn around, it can change the SSID to one of those. Now, what that means is that if your device is sending out a probe request for my home network, and the pineapple then says, yeah, I'm your home network, if you didn't have any encryption on that network, no WEP, WPA, WPA2, they get together. You don't even have to take the phone out of your pocket and you're connected. And that's why people yesterday were going, hang on a second, what's going on here? Why am I connected to home? Or the coffee shop or whatever. There are 100 people yesterday, and these are your device names. So there's 75 device names there. There's about another 25 where the device names didn't come up, that automatically connected. Okay, so in many cases here, you didn't take this out of your pocket, it just connected automatically. Now, what could we do if you had connected automatically? Well, the good news is we didn't do anything other than look at what they were connecting to in terms of the SSID name. What you could do is you could capture every single packet that went through that connection. Now, the point of all this in relation to application security is that, yes, our devices do these things. They send probe requests. They jump into bed with any SSID that looks familiar, and they're very sort of promiscuous that way. But it's only a problem when the application doesn't properly protect the transport layer. So in my example before, that is a problem because the login form was loaded over HTTP. If you get pineappled and you load that form, you could have a keylogger in there. So the reason I've done all this is to make the point that it is very, very easy to hijack someone's traffic. Now, this is via Wi-Fi. There are other examples, and one that I often use, is in Tunisia a few years ago when they had a lot of political upset there. The government owned the ISPs, and they decided that they wanted everyone's Facebook credentials. Facebook was loading their pages, their login pages, over HTTP. So the government just went, okay, you can have the login page, and here's a keylogger. And they did exactly what I just showed you here, and they did it to an entire country. Thousands and thousands of Facebook credentials, and God knows what happened to the people that did actually get their credentials stolen, and the government could find out what they were saying. So it happens, and it's real, and that's why HTTPS is so important. All right, let's move on. Something completely different. Password storage. So who is storing their passwords like this? Hashes. Some people. All right, so a little bit of password 101. So the theory of using a hash for password storage. So a hash is a one-way deterministic algorithm. And what we mean by that is that you pass a piece of text into the algorithm. So let's imagine, again, it's password with a 0 instead of an O so that nobody can figure it out. And what the hash does is the hash applies a one-way deterministic algorithm, which means that the cipher that is output from the hashing algorithm can never be unhashed. You cannot take a hash and go back the other way. It's not like encryption where there's a key, and if you have the key, you can actually unlock it and get back the other way. So that's the one-way part. The deterministic part is that if you enter the same text into the same hashing algorithm, it doesn't matter where it is on what machine, you'll always get the same end result. Now, the reason this worked well for password storage is it means that if your database gets breached and they get your passwords, they're actually getting hashes, okay? And they can't decrypt the hashes. Now, compare that to, say, plaintext storage. You store data in plain text and, look, you're stuffed. I mean, there's no cryptographic protection whatsoever. Encryption isn't much better. You store it with encryption. A lot of the time, the entire machine gets compromised, the encryption key gets compromised as well, and the attacker just goes through and decrypts it. So you've got a problem then as well. Now, there's a problem with hashing, though, and the problem is because it is deterministic, once you create a hash of a password, it's always going to be the same no matter where you hash it. So what this meant is that attackers could go through and take a word list. Okay, so let's take, say, a common list of words that people use for passwords, create all the hashes with, say, SHA-1, and then the next time there's a breach, they just compare that list of hashes with the compromised list of hashes, and when you get a match, they know the password that it was. So this is where things like rainbow tables came in. The idea of rainbow tables was you could take, say, 6 to 9 characters, alphanumeric, with a number, and create every single possible SHA-1 hash. You end up with tens or hundreds of gigabytes worth of data, but it means that when you get a database breach, you just feed it in and it just goes through and says, okay, well, this hash is actually that plain text, that hash, that plain text. So it made it pretty useless. So what do? We added salt. Now, the idea of salt is just random bytes. So for example, let's say 16 random bytes is fairly common. Now what happens is you have a salt and you have a password, so salt is just randomness. You add it to the password, then you hash them together. And then in the database, you save that cipher, so the result of the hashing exercise, and you save the salt. And normally they get base 64 encoded so that it goes into things that only want to like ASCII. I'll give you an example of that in a moment. Okay, so that's what happens. Now what happens then is when someone logs in, they provide a username and a password. The application takes the username, it goes to the database, gets the salt, and it gets the hashed password and salt, and then it just repeats the process. So the app then says, okay, now I've got the salt, I'm going to take the password you just provided to me, combine them, hash them, does it match the hash in the database? If it does, yes, you log in. Now what that means is that we then end up with an algorithm that looks a little bit like this, hash of password plus salt. And there are arguments about whether or not that's the right way around as well. But that aside, the context or the concept is still the same. Now what it means is that in your database you end up with a lot of stuff that looks like this. Okay, so you end up with a whole bunch of salts and a whole bunch of hashes. And here's the next demo I want to do. So this is basically just a collection of salts and hashes, and this is all from ASP.NET's membership provider. So if you use, and ASP.NET's membership provider is just sort of the out-of-the-box default, okay? If you set up a brand new website and you use all their defaults, this is what you're going to get. Now let's go and show how useless this is. And it's not just ASP.NET as well. Any time that SHA-1 or MD5 or any of these hashing algorithms are used with a salt, it's pretty much the same deal. So here's what we've got. On my PC here, I have got a file called salted hashes. Now this is actually arranged in a little bit of a pattern. It's got a prefix here, and this prefix is just because EpiServer is the server that follows this pattern, and the guys that created the tool I'm about to use decided to prefix it with EpiServer. Here's our salt, and here's our hashed password. Okay, and there are 30 records. All right, so this is the sort of thing that happens in a breach, right? So some 3-year-old goes and hacks a database and gets all the passwords. This is the sort of stuff that comes out. Now, the other thing that I've got here is I have got a password dictionary, and it's a password dictionary called HashKiller. Now, the idea of a password dictionary is it's not like an Oxford or a Cambridge with lots of English words. You'll see some English words. But what it is just a massive collection of the sorts of strings that people use as passwords. I say strings because obviously a lot of these aren't actually words. And in fact, as you go through these, you just see that there are lots of sort of random stuff. If we go all the way to the end, we should see that there are over 23 million of these. It'll eventually get to the end. It's going slow. Anyway, so the point is a lot of these come from previous breaches. So particularly where systems have stored passwords in plain text and they don't have to go through any sort of cryptographic reversal process. And there are a lot of breaches that have come from plain text databases. What happens is these dictionaries get built up. So this one's got about 23 million words. And obviously words include lots of punctuation and other things like that. What I'm going to do now is go and run a little command over here, and the command I'm going to run, all it's going to do, it's going to call into a program called Hashcat. So Hashcat is free software on the internet, and Hashcat is GPU-accelerated password cracking software. GPUs are extremely fast at doing password hashing. Now what it's going to do is it's going to take in my salted hashes, so my 30 salted hash passwords, and it is also going to take in the HashKiller dictionary. And when I run this, we'll see what happens. Now, what we're seeing first of all is that my mouse doesn't work anymore, which is going to make this interesting. But the rest of what we're seeing here is we're seeing the strings that we passed in, so you can see EpiServer, you can see the salt, you can see the hash. Now, right over on the right, you're actually seeing the password. That's the plain text password. First password with Lenny, with a hash either side. Then it was all ones. We go down, ABC 123, that's always a very popular one, unfortunately. Baseball. These are the plain text passwords. So this is SHA-1 salted hashes, which many people consider to be a secure way of storing passwords, being hacked one by one by one by one. Now, we're not breaking the algorithm here. All we're doing is repeating the hashing process. Now, because I can't actually point to things with my mouse, let me try and explain what we're looking at. We're seeing a summary down the bottom. And if you look, we see there's a session name, there's a status, there is an input mode. Go down to, say, time started. Now, at the end of time started, in brackets, is 39 seconds. It took 39 seconds to crack these passwords, salted SHA-1 hashes. Now, it was only 30 of them, but this is my laptop. It's an old laptop with a little GPU. So it's nothing too special. Go down a couple of more lines. We see speed, GPU number 1, 6,272. Killer hashes. So that's 6.2 million hashes per second. It was recomputing. Now, I know what you're thinking. This is slow, right? And it is. It is actually very, very slow. Using consumer-level hardware and doing everything in the GPU, you can do with SHA-1, you can do about 2 billion hashes a second. And by everything in the GPU, what I mean is that rather than feeding in a password list, it can do things like mutations. So it'll do things like substitute zeros for O's and things like that, or vice versa. So it can be extremely fast. And this is the crux of the problem. Our password hashing is too fast. So when you use something like SHA-1 with Assault, the whole thing just absolutely flies. Now, the answer is that there are numerous password algorithms, password hashing algorithms, that work extremely slowly. So you hear about things like bcrypt or pbkdf2 or script. And these work somewhere between normally 1,000 times faster than this is a baseline. And really what we're saying is, let's make it take 1,000 times longer. So it doesn't make it unhackable, but if it takes 1,000 times longer, it's going to be a whole lot harder to get anything useful. That's a baseline. Most of the guidance now seems to be about 5,000 or 10,000 times slower than what this is. So if you're using SHA-1 hashes with Assault, and you're only doing it once, and sorry, it's not just SHA-1, it could be 256 or 512 or MD5, God love it. If you're doing any of those sort of things, it's pretty much useless if you're just doing one round. Okay, so I think we can go mouse-free for the rest of this. I hope we can. All right, so I want to move on. I want to talk a little bit about devices, because a lot of people have been talking about devices over the last few days. And I find that there are some very interesting security and ramifications coming with devices. And partly it's because everyone wants to rush these things out, right? You see the range of different things that are coming out device-wise. So has anyone seen this one? No, this one is? All right, this is one of the more odd devices. So I'll give you a hint. It's a device, of course, it has a companion app. Everything's got to have a companion app, okay? And you use the companion app to put the dog food in there, all right? And the dog comes along and he eats out of there. So you can go to work and then go, oh shit, I forgot to feed the dog. That's all right, I'll pull out my smartphone. So here's the interesting thing, right? This is all hitting APIs. And everyone now knows how to find the APIs and the HTTP requests behind the device. And everyone now knows how screwy a lot of them are in terms of their SSL implementations as well. Now, overfeeding your dog is one thing if an attacker gets in, but it can get worse. Everyone seen this one? Now, everyone's obviously just realised, oh my God, I needed an internet-connected fork. I never realised it. But I needed it. I showed this in a presentation last month, and someone said, you know what, we should just zap people if they eat too much. So this is a happy fork, HAPI fork. And look, it's kind of cool because it says every time you take a bite, it's obviously got motion sensors in it and it knows that you're eating, and you can sort of see from the graphs and things in the background, it will tell you it's like your fork to mouth ratio per minute or something ridiculous like that. But inevitably it's popular. And guess what? It's got APIs and things like that behind it. But let me talk about my favourite, and this is sort of the end here. So has anyone seen this one? Okay. You just don't even know where to start with this. So someone, and by someone I mean the Japanese, have decided that what you really need to be able to do is control your toilet via your phone. There's actually just a glimmer of sense in this, because it kind of means you don't have to touch stuff, because you can just, look, everyone plays bloody Angry Birds on the toilet anyway, you've got your phone with you. They can use it to open the seat, to work the bidet function. And I'll tell you, there's a true story. I showed this a few months ago, and I said, look, this is the sort of thing that we need to be conscious about security-wise, because, we are building APIs and interfaces. We're going to have security vulnerabilities. And wouldn't you believe it, there's a vulnerability in the bloody toilet. Okay? So this was released only a few weeks ago, and I love the summary of it at the end of it. I'll just let you read this. I'm not worried about my passwords, I'm worried about this. Okay, so I think I'm going to end it with a bit of toilet humour there. So thank you very much, everyone, for coming. If anybody does want Pluralsight passes, I've got a whole heap of them here as well. Thank you.
Thanks very much, Troy. We've got a few moments for questions, so there's got to be some questions out of that. Really?
Which, sorry? The SQL injection tool? Yeah. Okay, so does the SQL injection tool suggest how to fix it? No, it doesn't, which also begs the question, how much of a penetration tester tool is it and how much of a script kiddie tool is it? No, it doesn't. My blog suggests how to fix it. So, yeah, unfortunately it's just for breaking stuff, not fixing stuff.
Is there a tool that identifies the issues and suggests fixes?
Yeah, so there are sort of two classes of tools. So there are static analysis tools, which will look at code, and there are various tools around. It really depends on the language, because obviously the implementation of database connections differs by language. So that's static analysis. Number two is dynamic analysis. So there are a lot of tools around, and effectively Havage was dynamic analysis in that it is hitting a live running application. So that's one example. There are tools like NetSparker. You can get a free one where you just point at a URL and it goes through and tries to attack a running website, and it will come back and tell you risks. And there's a bunch of other, often very expensive tools that do similar things.
At the start of your presentation, you had the slides with all the companies being hacked and things like that.
Yeah.
And it seems to be more common and common. And basically what the companies do is go, oh, throw their hands up, we got hacked, really, really sorry. Is there anything coming forward in the future to kind of regulate bigger companies dealing with a lot of data?
Yeah, it's a good question. And a lot of people say that because compare it to something like aviation, and okay, people die if you get it wrong in aviation, but you've got CASA and all sorts of things that actually regulate the industry. We don't tend to have that. We have glimmers of it. So something like PCI, so the payment card industry, has standards for if you are building software, then you've got to follow various practices. If you're building medical equipment or things like that, there are governing bodies like the TGA that are going to have oversight on it. But we don't really have anything in terms of a governing body for software developers for security. I think the closest we get is we're starting to get things like mandatory disclosure laws. So the other countries have had this for a while. If you get owned, then you must publicly disclose it because there's an impact on your customers. But at the moment, there's really not a lot to hold people to account when this happens. And even when it does happen in places like the US and everyone's as litigious as anything else, when LinkedIn got owned a little while ago and a bunch of stuff released, people tried to take class actions and it just didn't go anywhere. So it's, other than reputation damage, there's not a lot you can do. And sorry, incidentally, this is everyone who's connected to the Pineapple now, just in case you're within range. Oh, geez.
You referred to doing one round of hashing. So if you do multiple rounds of hashing, is that more effective than just using a slow hashing algorithm? What's the relative benefits of one over the other?
Yeah, it's look, most of them. The problem is that when it comes down to workload, the effectiveness of it is going to differ depending on the equipment it's running on. In fact, in one way, it's a little bit unfair because when we build applications that do hash passwords and store them, it happens on a server, it happens in a CPU. When attackers attack web applications, they run it in the GPU. The GPU runs about 100 times faster. So already as web developers, we're sort of well behind the arms race. In terms of then the workload, it's a little bit counterintuitive because we want to make everything fast, right? Everything's got to be fast. But then for hashes, we're trying to make it as slow as possible. And we make it slow by making it really hard on the CPU. Now, you make it really hard on the CPU, and then you have a risk where, well, does that mean someone can DOS me? Do we just keep making requests to the logon facility because I know that every time it tries to log on, it's got to hash this thing 10,000 times or something and put massive load on the CPU. So it does depend on the algorithm, though. So things like bcrypt run exponentially. So when we talk about rounds, I think they refer to it as like workload, and you can have a workload of 5, which is double the overhead as 4 or 6. So it depends. Something like PBKDF2, then you actually give it a number, and it does however many rounds. So it differs by the algorithm.
Isn't that just another unknown for people trying to crack passwords? So they don't know how many times the password's been hashed, therefore they need to try and break it until they get one that's correct. Yeah,
that's a good question. So it really comes down to, are you trying to actually hide the implementation? So there's this principle called Kickoffs Principal or Kickoffs Law where he basically says, look, any cryptographic system, everything but the key should be publicly known, or you should assume that it's publicly known. Because what tends to happen is when an application does get owned, let's say it's an ASP.NET application. We know the implementation of the hashing algorithm. If you go and create a brand new project, you see it right there, so it's not held as a secret. Other people will say, well, should I actually hash it with one algorithm and then hash it with another one and then another one? Yeah, but if you get the application code, then you find out. And then they say, okay, well, what if I actually, with my salt, I also add another static piece of data from somewhere else on another server? And they try to sort of spread that risk out more. So there are ways that you can, I think, kind of chip away at it a little bit, but it also, it's always a little bit of an arms race as well, isn't it?
Right.